Hi, this is Crystal here. This is my third attempt at doing a code review because I've got my boyfriend's computer and I don't have my Xbox screen recorder, and because I don't have my Xbox screen recorder, I'm having to use an online screen recorder. So this is number 3 of this code review. So it's going to be quite quick because I don't know how much time I have in the code review. Basically, it's a Eurecom Tweets competition question in Kaggle, and I used the Kaggle Jupyter Notebook to make the competition question. The reason why I can't do more competition questions is because the data sets are so large that I'm not able to I'm not able to do it because I don't have the capacity on my computer to do it. And I wonder a little bit about Kaggle as well, because I don't think Kaggle has the capacity to do these really large data sets either. So I'm not happy about having really large data sets, but that's the way we're going. We're going into big data, and I can't do big data. So what we're going to do is we're going to do the code review. We're going to do the problem statement. I'm going to have to work quickly because I don't know how long this screen recorder is going to work. But we're going to do the problem statement, which is, for this challenge, students are provided with tweets from Figure 8's data for every one platform. Your task will be to classify tweets with positive, neutral, or negative labels reflecting the sentiment of the user writing the tweet. So the first thing I do is I'm going to import my libraries. I'm going to import NumPy, Pandas, Matplotlib, Seaborn, Warnings, OS, Spacy, and sklearn. So NumPy is to do numerical calculations and create NumPy data frames. Pandas is to create and manipulate data frames. I'm sorry about the NumPy. NumPy doesn't create NumPy data frames. It creates NumPy arrays. Matplotlib is a graphic library that helps you plot your points. Seaborn is a more sophisticated library that enables you to do statistical analysis on your graphics. Warnings is just a library to do with warnings. OS goes into the operating system to retrieve the files that you're going to use in the program. Spacy is your sentiment analysis library, and sklearn is your machine learning library. So after we've imported our libraries, we're going to use OS to load up the data frames or data sets that we're going to use. And the 3 data sets we have are train, test, and sample submission. Then after we've loaded the data sets up, we're going to use Pandas to read them. So we've got train, test, and submission. You can see train, it has a text ID, text, selected text, and sentiment. You'll notice that the sentiments are in words. So in order to make predictions, we're going to have to take the sentiments and convert them to numbers, which we will do that in the program. Look at test. Test is the same as train, only it doesn't have a sentiment and it's a smaller file. And then we look at submission. This is what they want to see. This is what the Kaggle wants to see when you submit your predictions. Now what we're going to do is we're going to analyze target. We're going to use Seaborn's hisplot to analyze the target. I think that if I had put something else in here, it would have given me a little line as well. But I didn't put something else in there, so you didn't get your line. Then what we're going to do is we're going to convert the sentiment to numbers. So you've got negative is -1, neutral is 0, and positive is 1. So you can see that we have replaced the words with numbers, and then that's going to be easier when we make our calculations. We make our predictions, sorry. And now what we've done is we've done a little box plot, so you can see -1 is the lower end, 0 is your middle, and +1 is your positive end. So now what we do is we do a value count, so we can count how many tweets are neutral, positive, and negative. And you can see we have more neutral tweets than we do positive and negative. We check our percentages as well. And now what you want to do is you want to check to see, compare the test tweets with the trained tweets, and you can see that there are a lot more trained tweets than there are test tweets. Now what we're going to do is we're going to define our target. Your target is your sentiment column on train. And then what we're going to do is we're going to combine the train and the test data sets, and you're going to do that by dropping the sentiment and then appending the test. So now we're going to count the words that we're going to process. So we're going to say tweets equals conv selected test, and you're going to count the words. So that's going to be 201,616 words it has to count. Now what we're going to do is we're going to process the text. So we're going to import RE from nltk.corpus, import stop words. So we're going to clean the text. So we're going to convert all the tweets to lowercase. We're going to remove special characters and numbers. We're going to remove hashtags. We're going to remove any word less than 2 characters. We're going to remove the stop words, and we're going to count. So now you have 105,806 words, so it's reduced the words. So now we're going to remove frequently used words. And then after we've removed the frequently used words, we're going to count them. So now you've got 90,090, so you have even less words. Now what we're doing is we're putting the dictionaries into the program. So we've got the apostrophe dictionary. You've got the short word dictionary. And you've got the emoticon dictionary. And then so now what we do is we create a function that will replace the words that are in the dictionaries with the words they want you to have. And then we use lambda functions to use that function with apostrophe dictionary, short word dictionary, and emoticon dictionary. So we're going to remove rare words. And after we removed rare words, because there's no point, if you only have like one word, there's no point keeping it in there to be analyzed, because it can't analyze it. It doesn't have anything to compare it to. So after we've removed rare words, we have 79319. So now we create our tokens in Spacy. So what you have to do is you have to install Spacy. And then we have to download Spacy in the English version. Okay, so now what we're going to do is we're going to use the code. So we import Spacy, import spacy.cli, and then we're going to download and load. We're going to use Core Web LG. And what I did, and the last time that I did Spacy, it was with disaster tweets, and it was vectors, and it didn't work with vectors, so now we're using Core. So we've got some more code that we're going to use with your Spacy. And then we do a token to vector. And then we do sentence to vector using pipe. And then when you use the pipe, it's going to be 27,480 rows by 300 columns. And now what we do is, after we've done all that, we define our X and our Y. So your Y is your target, your X is your tweets vector up to the length of train, and then your X test is the tweets vector from the length of train. Now we're going to split data set for training and testing, and we're going to use sklearn to do that, and only 10% of the train test is going to be for validation. Now we select model, and in this instance we used linear SVC, and when we used linear SVC we only got 75% accuracy, but we did get some accuracy. So we predict on our validation set, and we've got 74% accuracy when we predicted on our validation set. And we created a data frame so you can compare the actual values against the predicted values. Now what we're going to do is we're going to predict on our data set. Predict on our test set. So you can see we predicted on the test set, and then we prepare that for submission, and you can see that this is what we have submitted to Kaggle. When I submitted it to Kaggle, I only had 72% accuracy, but that's enough to get you on the leaderboard. And what I wanted to say is, these people that win these competitions, what they do is they go through and they look at other people's codes and see if there's something that was used in somebody else's code that they can use in their code to improve their scores. And so that's how you do it. If you want to win a competition, that's how you do it. But my situation is I'm under a lot of pressure to create content. And since I'm under a lot of pressure to create content, I haven't got the time to look at other people's code and say, oh, well, maybe I can use this and improve my score. But if you've got the time, and you want to win a competition, that's pretty much how you have to do it. But I don't have the time to do that, to look at other people's codes and see, can I improve my score using that methodology. I also wanted to say, I don't know if I mentioned this, that you can use sklearn sentiment analysis if you don't want to use Spacy. One thing that I noticed when I was using Spacy, I had to troubleshoot a lot. I think sklearn probably is more stable, but I think I got better results with Spacy. But what I might do, if I have the time, is I might go ahead and do this Eurecom with the sklearn, and so that way you can see how it's done with Spacy, and then you can also see how it's done with sklearn, so you can decide the one that you want to use. And what I want to do is I want to thank all of my subscribers for subscribing to my channel. If you like this video, please like, subscribe, and share. Thank you so much for watching this video, and I look forward to making more videos for you in the future.